LeetCode problem 1372, longest zigzag path in a binary tree. You are given the root of a binary tree. A zigzag path for a binary tree is defined as follows. Choose any node in a binary tree and a direction, right or left. If the current direction is right, move to the right child of the current node, otherwise move to the left child. Change the direction from left to right or from left to right or from right to left. Repeat the second and third steps until you can't move in the tree. The zigzag length is defined as the number of nodes visited minus 1. A single node has a length of 0. Okay. And that's because we start at 0 for index. Return the longest zigzag path in that tree. Alright. So 1, 2, 3, 4, 3 because minus 1. So we have 1. Okay. So we have 1. Try to go right first. And then since we are right, we have to go left. Since we're at left, we have to go right. Since we're at right, we have to go left. There's no left. So that's the end. We count them. Count them up. It's 4 minus 1 equals 3. Okay, so here, 1 we go left, means we go right. Right means we go left. Left means we go right. So we have 5 minus 1, 4. And then this is 0 because we only have a tree node, root node. Okay. Easy to understand. It's gonna be kind of hard to code. Okay, so we know for sure we're probably gonna need a variable to keep track of the max length. And then we can use a stack again. We're gonna need a way to keep track of our left and our right. And that should be it, right? But I still don't really. Let's look at some discussion questions. This one's a little bit hard. Oh, I got rejected for McDonald's because I couldn't solve this in an interview. I told to solve the question. I'm glad I solved this one. Ooh. When I'm doing the solution in O and getting time. Just try a recursive solution and maintain left or right left lengths and pass it accordingly. If you're going to the left side or right side and return the max of 2 calls. Okay. Let me just do mine. crashes. Dang. We've been missing it a few times. It hasn't been working out. Okay. So we have this. Let me look at more. Use queue to store path length, next queue, and where it was from. Use DFS to traverse. Return the length of the longest zip path, not the longest. Okay. DFS is much, but not straightforward. Nice one. Okay, so what are we going to do? We can use a stack again. Okay. We're gonna have our node as always. And we're gonna have zero for our length, right, which is an int. And then we need a way to track our left and our right. So let's do this. We can use true or false, false, true, false, left, true, right. I can do a stack. Something like this. That will give us, one will be from the left side, one will be from the right side. We're starting both at the same time. So we can do this, do this, and do this. So this will be our left, this will be our right, and then we just do our loop. So whilst the stack is not empty, we want to set up our node. Do we have a node? No. How do we do it? No, it's this. That we remove. And then we can set our length. We need to change this. We need to change this so I don't confuse myself. So we need to set this to equal our max. Right, so we're gonna have our longest, then our excuse me, our length. Sorry, let me charge my laptop. So we have our longest, and then we need to loop. Okay, so we have our longest length so far. What we need to do. If we're from the left side, we're gonna do something else. That means we're on the right side. So this is where we should be doing our appending. So if we're coming from the left side, we need to go right. So if we're coming from the left side, let's do if let right node equals node dot right. We do our stack append. And then we are going to append our, if we're coming from the right, we're going to append our right node. And then what's this? Right node. What did I say? Right node. False is left. False is left. So we're going to do false. And we're going to do 0. No. We're going to do +1. We're going to increase. But what do we want to increase? We want to increase the length. We're going to increase the length +1. Alright, so if it's a right node, we need to do one for the left too. Left. And this one we're not going to increase the length. We're just gonna do stack append left node true 0. So if we're going left, if we go left again, that means we're trying to do a new path. So since we're supposed to alternate, let's check here. Since we're supposed to alternate, so if we went right, no, if we go right, left, right, left. So if we go right and we go right again, that means we're starting, this is starting a new path. So we're not taking this into consideration. Okay, I think. So let's do the same thing for our else. For our else, that means we went right side first. Oh my god. True, and then we'll just do this. No, this is gonna come back and bite me. Okay, so if we came from the right side, we should go left so that we are still zigzagging. So we got the left node, we're appending the left node, and then we're increasing. Or if we go right again, that means we're starting over. Okay, and then we return our longest. Okay, let's try. Expects a simple parameter. Pool length and solution. Instant append expects a symmetrical parameter left, right. So we're passing in true node. We're passing in a bool. We're passing in an integer. Okay. I need to put these into wrong answer. So wait, why is this one wrong? Okay, so we have our guard statement. So that's not it. We have our longest. We have our stack. Okay, so while it's not empty, we remove our last. Our max length is our longest. The max between our longest and our length. Okay. If right child get node right, stack append for our right node left, and then we increase it by 1. And if we're going to the left, our left node true 0. Okay, then else if we're on the left, we do left, append the left node true +1, and the right node right child false 0. Okay. Why is this not passing? Let's see if this is any help. Only half of the test cases. Okay. We have this. We have our longest. We have our stack. Our stack. Okay, so we're letting node remove last. Max length. We have our max length. Okay, so it has to be somewhere in here. So if we have our left side, if we're from the left side, if we came from the left, we should go right to continue to zigzag and flat right node, which is node right. We append right node false for left length +1. Left node, we go left, append true for right 0. Okay. What am I missing? Let's try this. Wait, that actually worked. Okay, 46 out of the 58 test cases. So I should have been using 1 instead of 0. That's the link. Okay. 9 milliseconds, 89%, which is crazy that there's other people that got lower. Okay. Let's look at some solutions. 18 people. Okay, so this is, I believe, using a recursive function. Is this using? Okay, yeah, so this it has its own function that returns. Oh, that now is really doing a lot. A lot of people are using two functions. I need to try that. Is there a traverse? Oh, this is his own function. Okay. So that was LeetCode problem 1372, longest zigzag path in a binary tree.